evaluate lim x tends to 0, y tends to 0, x cubed plus y cubed. Now, in this example, we will evaluate the limits of x cubed plus y cubed as both x and y approaches 0. First, we evaluate along the path where y equals to 0. That is, substitute y equals to 0 into the equation. So we have lim as x tends to 0, x cubed plus 0 cubed. So that will give us lim as x tends to 0, x cubed equals to 0. So let's label this first result as f1 equals to 0. Next, we evaluate along the path where x equals to 0. That is, let's substitute x equals to 0 into the equation. So we have limit as y tends to 0, 0 cubed plus y cubed. So that will give us lim as y tends to 0, y cubed equals to 0. So let's label this second result as f2 equals to 0. Okay, now we also check along the path y equals to mx. That is to confirm the limit is consistent. That's the main reason for this. So let's substitute y equals to mx into the equation. So we'll have limit as x tends to 0, as x cubed plus mx cubed equals to limit as x tends to 0, x cubed plus m cubed x cubed. So that will give us limit as x tends to 0, x cubed 1 plus m raised to power 3 equals to 0. So let's label this as f3 equals to 0. Finally, we have to verify with y equals to mx squared to ensure that the result holds for all paths. So let's substitute y equals to mx squared into the equation. So we're having limit as x tends to 0, x cubed plus mx squared into cube. That is, we'll have limit as x tends to 0, x cubed plus mx cubed, x raised to power 6. So we factorize it to have lim as x tends to 0, x cubed, bracket 1 plus m cubed x cubed equals to 0. So let's label this f4 equals to 0. Okay, since f1 is equals to f2 equals to f3 equals to f4 equals to 0, the limit exists and its value is 0. So, and that is how we can evaluate multivariable limits using different paths. See you in the next video.